Tonight, episode 4, the metamorphosis of Ajax. All the world's a page and all the men and women merely pointers and clickers. Tonight we're going to start with a contemporary of William Shakespeare, Sir John Harington, author, poet, the saucy godson of Queen Elizabeth, and he's best remembered today as an inventor. He invented one of the most important inventions in the history of civilization. In fact, the thing which made our modern civilization possible. Without it, life would be horrible. This was his invention, the flush toilet. You see Reservoir A, which he fancifully fills with fish. He's a poet. The user interface, there is D at the seat board. F is the control by which the user can cause water to drain from the reservoir down, flushing the stool pot and keeping everything clean and fresh and sweet. In Harington's time, getting rid of human waste turned out to be a huge problem. The prevailing technologies of the time were cesspits and chamber pots, which tended to be emptied out of open windows onto the street or whatever happened to be out there. Cities and castles and places where you had a lot of people smelled really, really bad. And there was also huge opportunities for disease. Queen Elizabeth herself was quite annoyed at the way her castle smelled. She complained about it quite bitterly. And at the time, they hadn't developed germ theory yet, so they believed that those smells were actually the cause of disease. This invention promised to be the solution to that. So you'd think that, hooray, at last we got flush toilets, we can clean this stuff up and get good. It didn't turn out that way. The Queen, he built one of these devices for the Queen, and she didn't like it. And she didn't like it because of the noise it made, that it announced to everybody in the castle that the Queen had just done her royal business. And she liked that even less than the threat of disease, which again she thought was spread by smell, and she definitely smelled what was going on. It was awful and offensive. It turned out, once we had germ theory, that we knew that it was actually caused by fecal contamination of the drinking water. Even so, it was a real problem. But it was not an acceptable solution. It was over 2 centuries before further inventors came along and refined Harington's invention, adding things like the S-trap and the siphon and the float valve, which made modern life today possible. Interesting thing about, I had a great aunt who lived on a farmhouse in Minnesota, and she had an outhouse. And so during the awful, brutal Minnesota winters, she would go out to the outhouse to do her royal business. And she was asked, why don't you get a toilet? And she said, you don't shit in the house. The reason I'm telling you this story is because of the invention that Harington gave, or the name Harington gave to his invention. He called it Ajax. In fact, he wrote a book about it called The Metamorphosis of Ajax, which is the theme of tonight's talk. So now let's fast forward about 409 years and meet this fellow, Jesse James Garrett. Garrett was the founder of a consulting company, Adaptive Path. He's not a programmer, he's a user experience designer, very good one. And he was working on an assignment with some developers who were trying to create a much more effective, useful web application. And they wanted to use techniques which, instead of doing a page replacement in response to each user action, that they would actually communicate with the server and do a partial replacement of the page, which would be much faster. Garrett tested their idea. It tested extremely well. So the team wanted to go ahead and implement it, but it was a radically different way of developing applications than they'd ever done before, and they wanted management to buy off on it. And so they asked Garrett to make a presentation to management to get them permission to use this new technology. So Garrett thought a lot about their request, and the story goes that one day in the shower, it occurred to him what to call the thing he was going to take to their management, and he called it also Ajax. I think it would have been a better story if he'd actually been sitting on the throne doing his royal business. You know, there'd be some really nice continuity there. Let's say that's what happened. So Ajax changed everything. So to understand what it changed, let's step back and take a running start at this. We'll start with word processing. Word processing was was a phrase that IBM started passing around in the 60s, basically for intelligent typewriters. You could have a typewriter with some local storage. You could do editing within the local storage and then print out the page. There were basically two formats for word processors. There were binary formats, which tended to be proprietary. The binary formats were preferred because they were much more efficient. They could compress and be processed much more quickly. Then there were also textual formats, which tended to be open, there was nothing to protect. In the proprietary line, we saw standalone systems, mag card systems, then shared logic system, which were basically simple time-sharing systems that could support several word processing terminals simultaneously. Eventually, it just became a program that would run on a personal computer, so the idea of a word processing device disappeared, and now it's just a piece of software that we use. And one of the things that they were striving for is WYSIWYG. What you see is what you get. Well, it turns out that sometimes what you see is all there is, that sometimes there's more to a document than how it appears, that there might be some other structure, and if you can retain that structure, you have more options in terms of what you can do with it. So following the other thread, textual formats or open formats. This is a granddaddy of all of them. This is a language called Runoff. It was developed for the CTSS time-sharing system at MIT. Took off like a weed, spread to lots of other systems, very popular. It went on to influence work in Unix, like the ROF and TROF programs were descendants of Runoff. The idea was that you would have two kinds of lines. A line that started with a period was going to be a command line, and it would contain some sort of code and maybe some parameters that would somehow influence the modification of the document and preparing it for printing. And then lines that don't have a period at the beginning are just raw text, and they will be filled somehow to fill paragraph margins. You could have descriptive terms within the commands, although most people tended to use abbreviations, and so it was often very cryptic. Runoff had a big influence on an attorney at MIT named Charles Goldfarb. And he came up with a different idea that he called GML, Generalized Markup Language. You can see some clear similarities with the other one. In this case, he's now using colons as the command thing, and he's using period to turn the command off so that you could have text and command on the same line. That was an innovation he came up with. And one of his ideas was to take all of the display-oriented stuff out, so you were only talking about the structure of the document. So some of it, you can recognize there are tags in this thing, right? And some of them may appear sort of eerily familiar to you. That coincidence is not accidental. The one that you might not recognize is the EOL, but you can probably guess what that one's supposed to do. So as GML went through its evolution, first he had custom tags for closing. Then later he came up with a double colon as a thing that would close it. And then at some point he discovered angle brackets. Like, oh, angle brackets, that sort of changed the whole thing. And you all know what happened with that. So where did the idea for angle brackets come from? It came from here. Brian Reed's scheme. While Goldfarb was doing his stuff, Reed was a student at Carnegie Mellon. And he developed a document processing system called Scribe, which was the first time in history that anybody had gotten the separation between structure and presentation right. Brilliant system. He came up with an elegant, minimal language for expressing documents. There was only one reserved character in his language, which was the @ sign. And if it was followed by a word, then that word would be the name of an environment. And then you could have some block of text or nested stuff that came after it, which would be the input to that environment. And in order to give authors lots of options, he had 6 sets of quoting characters that you could use to define these blocks, one of them being a pair of angle brackets, which really impressed Goldfarb. Another nice thing he had was that for dealing with very long things or deeply nested things, he had special forms begin and end, in which you plug in the name of an environment, and then you don't have to worry about accidentally closing out of the contents. Scribe was a really elegant, very, very nice way of creating documents. It was very easy to write in it, and it was very easy to get things right. Another thing he had was support for bibliographies. So here are examples of declaring a tech report and a book. And the interesting thing about the way he does that is it looks like JSON. This is where the idea that you could represent data in a document format came from. This idea eventually got moved into the XML community, but unfortunately they didn't get enough of Reed's stuff to get it right. But what they did get from this was the idea of attributes. So later we're going to see attribute equal sign, equal some value. This is where that came from. So Scribe was very influential. Scribe inspired SGML, Standardized Generalized Markup Language. It also influenced LaTeX, which was a document processing mode for Donald Knuth's TeX, which is a brilliant typesetting system. The difficulty with TeX is it's probably the most powerful ever made because it's not just a document description language, it's actually a programming language. And so its complexity is maybe beyond what a lot of people are able to deal with, but it's really good stuff. And Lamport's LaTeX stuff made it significantly easier to use. SGML was a popular product at IBM's Federal Systems Division, but not much else. So if you happen to be in a governmental or quasi-governmental organization, there's a chance you might have been using SGML. The rest of the world said, yeah, we don't want that. So it was doing okay in its niche. Now it turns out one of the quasi-governmental institutions that was using SGML was CERN. And CERN was where Tim Berners-Lee was. Tim Berners-Lee adopted SGML as the language for his World Wide Web because that was what he knew and it was already used in-house. If CERN had been using Scribe, or if Lee had been more up to date on what had happened in the history of document processors, the world might be a much better place today than the world in which we are, but that's the way it turned out. Now the SGML guys were shocked at what he did to HTML. They were completely disgusted. He had broken their rules. Well, we'll get to that in a moment. So HTML was not state-of-the-art when it was introduced in the late 20th century. It was intended for simple document viewers and nothing else. That was its complete mission. It was not intended to be an application platform. It was not intended to be any of the things that we require it to be now. All of that stuff came later. So a lot of people looked at the World Wide Web as it was first proposed and thought it just didn't have what it takes. I was one of those. And in fact, we were right. But things happened and it changed. So web standards were grown from this naive hypertext system under intense, highly unstable competitive pressure. Not a good recipe for designing anything, but those were the conditions that created the world in which we live. It fundamentally was not designed to do all of this Ajax stuff. And its success is due primarily to a lot of very clever people who found ways to make it work in spite of its inherent intentional limitations. So HTML was, in my view, a huge improvement over SGML. The SGML community would bitterly disagree with that assessment, but I believe that it's true. The thing that he got right was he made it simpler. SGML was an insanely complicated system. It came from having a weak design and then churning and crufting on it until it was just crazy. Tim Berners-Lee just took almost everything out and left just this tiny skeletal set of tags, and that's pretty much all there was in HTML when he finished with it. So one of the improvements that he made that they were disgusted about was that it was more resilient. Eventually they developed the rule that if the browser saw a tag and it didn't recognize that tag, it wouldn't throw a fit, it would just ignore the tag and keep processing the text. That turned out to be an extremely important innovation because it allowed for extending the HTML language over time. Had he not done that, growing the web, maturing the web would have been impossible. Now, there was a dark side to that. The browser makers got into a competition of who could make sense out of the worst HTML. Under the theory that web developers were incompetent to write good HTML, which I don't think is completely the web developer's fault. I don't know if anybody has ever written a completely correct HTML page. It's just a surprisingly difficult format to work in. And I'd say that empirically because I just don't see very much good HTML in the world. So in that competition, they enabled bad coding. And because nobody wanted to have the browser that couldn't display a particular page, and so they would struggle to make sense out of really, really awful stuff. And because there was no enforcement of the browsers and no penalty against the developers for writing crappy stuff, they wrote a lot of crappy stuff. And so we had a fairly vicious loop going on there. One of the fundamentals of the original design of HTML was that the author has virtually no control over the presentation of the document. It turned out that having that control was important. I mean, sometimes we want pixel perfection over what gets displayed. HTML by design did not permit that, so that had to get added later. There's also a problem in that the set of tags is much too small for the set of things that we're doing. And so we end up having to do a lot of overloading, where we'll identify something as an unordered list, even if it isn't an unordered list. It might actually be a menu or a menu bar, but we don't have tags to represent that, so we call it an unordered list. And so we have to disambiguate all of that stuff, and so we end up having way too many classes or IDs in our page in order to overcome that. And it did not anticipate the applications beyond simple document retrieval. Virtually everything that we're doing today is out of scope for the original design of HTML. And there's some confusion even within its very simple tag sets. For example, it's got two completely different ways of writing outlines. There's OL and LI, which get nested, and then there's H1, H2, H3, which don't get nested. They do basically the same thing, but there's no consistency within the language as to how these features work. Also, am I the only person who's noticed that a web page is not a page? I don't know if that matters to anybody. It's not a page, it's a scroll. And scrolls are great. I mean, scrolls are ancient technology, and there's a lot of important wisdom that's been recorded on scrolls. But there was an important thing that happened at some point where we started cutting the scrolls into equal-sized pieces and binding them together to create books. And HTML has no sense of that at all. We've got these scrolls, which call themselves pages, and we have a site, which is a collection of pages, but there's no way you can really take a site and consider it as a book. I don't know if that's important or not. So when HTML became vastly more important than SGML ever was, the SGML community fought back. And they did that by infiltrating W3C and sort of taking it over. because they had very strong opinions about how markup should work, and the web development community didn't. And so it was very easy for them to take over that process. And so they started doing subtle things like changing P from a separator, as it was originally specified, into a container, and started the mythology of semantic markup, which is essentially impossible in a system in which you cannot make up your own tags, in which you're using a set of tags which was designed for simple technical documents, and you're coding things which have no resemblance to technical documents. There's no opportunity for semantic coding in the system as it currently exists, but there's a lot of belief that that's what we should be doing. Then, of course, there was the XML fiasco, in which the HTML community convinced W3C that they needed to throw HTML out and start over with a new simplified version of SGML, which they called XML. But it turned out it wasn't simpler. It eventually grew to be as complicated as SGML was. And bad things happened as a consequence of neglecting HTML, because it turned out that was the thing that there was market acceptance for. The XML flavor of HTML, XHTML, is really dead on arrival. One of the first follow-on standards after HTML was CSS, cascading style sheets. There's nothing about it which resembles sheets that I can represent, or that I can recognize. It seems a goofy name to me. And it's based on an unhealthy separation of structure and presentation. That difference made sense in Scribe and might have made sense in SGML because you had authors who were working with book designers. But in websites, very often you've got one person or one group of people who are trying to work collaboratively in order to make a thing which looks consistent in many variations. And CSS was not designed to do that. It was specifically designed for paper printing. So it really doesn't fit the dynamic world that we're working in now. You program with long, fragile lists of self-contradictory rules. The rules by which contradictions get resolved are very complicated and very error-prone. Each rule has two parts, a selector and a declaration. The whole mess is very difficult to understand, very difficult to use. I think there are fundamentally 5 problems with CSS. The first is its lack of modularity. We have lots of situations where we've got lots of independent content that we want to be able to display on the same page or scroll. But there's a very high likelihood that they're going to interfere with each other. If one contains a rule, that might accidentally override a rule that belongs to another one. And it's very difficult to detect those sorts of situations beforehand. And as we get more dynamic in the way we piece things together, it just makes life much more difficult going forward. It is possible to impose some modularity on things, but it's very, very difficult. It's not a natural expression within the language. Selector management is very complicated. I don't think this is entirely CSS's fault. I think a lot of it is actually HTML's fault. Since HTML has a small but rigid set of tags, we end up having to overload all of the tags. And then we rely on CSS to do the disambiguation. And that turns out to be a very complicated problem, and CSS solves it to an extent, but doesn't do it very well. The declaration part of the language is too weak for the kinds of layouts that we're dealing with today. We want to be able to have a single document which can display on a big terminal, and that can also display on a medium-sized laptop, and can also display on a portable device, on a mobile device. And we'd like to be able to express a set of rules which allows us to scale beautifully across all of those ranges of screen sizes. And CSS just doesn't do that. It was not intended to do that, which is why it can't. And then finally, and this might be the scariest of them all, is that it is unimplementable. The CSS2 specification could not be implemented. None of the browser makers were able to get it to work. So the committee had to reconvene and issued a new draft 2.1, which was based on what people had actually been able to figure out from the previous one that they could actually implement. And there's a similar thing happening with CSS3. All of the browser makers are now trying to implement CSS3. It's really hard, not just to do what it says, but to also do it efficiently. So everyone's doing it a piece at a time. Everybody's doing a different piece. In my view, the standard is failing there. It's just too difficult. It was not designed with enough awareness of how web applications are actually constructed, and it was not designed with enough knowledge of how web browsers actually have to work. But I find within the community of people who use CSS, great affection for it. They're totally invested in CSS. They love it. They can't imagine any other way of doing formatting in a document. It's it. It's sort of like watching an episode of Cops, you know, where the cops come in and break up the family dispute, and it says, CSS ain't bad. You just don't understand it like I do. I know it hurts me, but I make mistakes. I'm wrong, you know. CSS is awful. And it amazes me the way people get invested in it. It's like once you figure it out, kind of go, oh, okay, I see how I might be able to make it work. Then you flip from hating it to loving it and despising anybody who hasn't gone through what you've gone through. It doesn't make sense to me. So if that's all there had been, if that's all there was, the web would have been replaced by now. And I'll offer as evidence of that a statement made by George F. Colony, who is the chairman of the board and the CEO of Forrester Research in 2000. He said, another software technology will come along and kill off the web just as it killed news, Gopher et al. And that judgment day will arrive very soon in the next 2 to 3 years. And he and his firm and several other firms and a lot of other smart people were saying very similar things for several years. But it didn't happen the way he said. He was predicting a new thing that he was calling the X-Internet, the executable Internet, a new system in which instead of stupid pages and scrolls, that programs be transmitted around the web or around the Internet, and those programs would be delivering value, not static documents. And because the browser couldn't do that, it was going to go away and it was going to be replaced by something else, and companies such as mine that depended on browsers were going to be in for a very, very difficult time. By the way, the article in which he wrote this is no longer on the Forrester website, but it's at archive.org, so you can still go and find that. So the reason it didn't turn out the way he predicted was because of JavaScript. JavaScript was the component that everybody underestimated. JavaScript is what made the browser work and what kept it alive in spite of its obvious failings. On the other hand, there was the document object model, also known affectionately as the DOM. It is what most people hate when they say they hate JavaScript. Most of the people who say they hate JavaScript don't know JavaScript, might have never seen JavaScript, but they've felt the DOM all right. And if you don't know what the difference is and you say JavaScript is the stupidest thing I've ever seen, but they're not talking about JavaScript, they're talking about the DOM. The DOM is the browser's API. It is the interface it provides JavaScript for manipulating documents. There are a lot of people who had a hand in the design and development of the DOM. I'm going to talk about two of the most important of them, but there were many others. The first was Brendan Eich of Netscape. Remember, we met him previously. He was the inventor of JavaScript. Brilliant stuff in JavaScript, not so brilliant here. He was given a book by Danny Goodman of HyperCard, and told, make the browser act like that. So he read the book and figured, okay, you got OnClick, you got this, and he came up with the level 0 DOM. Some years later, Scott Isaacs at Microsoft took his hand at it and made some significant improvements to the DOM. Didn't go nearly far enough, in my opinion, or in his, but he did that. He also invented the iframe. You've heard of the iframe, the Isaacs frame. He says that's not why it's called the iframe, but I know better. So in the original Netscape model, not all elements were scriptable. It was a much smaller set of elements that were scriptable, mainly elements that mapped onto things that were scriptable in HyperCard. In the Microsoft model, every element was scriptable and completely scriptable. And so any element could be moved or colored or rearranged or whatever you want. So it was a much more powerful, much more expressive programming model, but it wasn't complete. He didn't finish it. Ajax had another advantage over Ike in that Ajax had designed applications. And so he had some experience at what was necessary in order to do this kind of work. It's a level of experience and insight that most browser makers do not have. And so he was well informed by that, and the DOM improved significantly as a result of that. So this is a flowchart of the first web browser. We start by putting a URL in, which goes to the fetch engine, which will then go out and find it and store it in the cache. It will then be handed to the parse engine, which will parse the HTML, find all the tags, all the text, and weave them together into a tree, into a data structure that represents that stuff. That then gets given to a flow engine or a layout engine, which figures out the size of each of the components on the page and their relative position on the page. And then that produces a display list, which could be a separate structure or it could be annotations on the tree. And then that gets handed to the paint engine, which will figure out how to take all of those things and turn them into pixels and put them on the screen or send them to the printer. All web browsers work like this, and they always have from the beginning. But the Mosaic browser, developed at University of Illinois at Urbana, did something a little differently. They invented the image tag. And in the image tag would cause other components to be loaded into the page. So they added some additional paths on this. So when the parse engine saw an image tag, it would stop, call the fetch engine to get the thing, that, passing it the URL that came with the image tag, and wait for it to come back with the stuff, and then it would continue. And if it found another image tag, it would then stop parsing, go back to fetch, and so on. This worked great if you were accessing their server on a high-speed network, but if you were accessing on a dial-up modem, it was pretty awful because you wouldn't see anything until after every image on the page had been fetched. So at Netscape, they added another innovation to this. When the parse engine found an image tag, it would send a request to the fetch engine to go and get it, but it would also put a placeholder into the display list and then keep on parsing. And we'll go all the way through to the end in Flow and Paint, and then later when the fetch engine finally delivers the image, they will then do it again and keep doing it over and over again, reflowing and repainting until finally everything shows up. So technically this takes a little bit longer and uses a lot more compute time, but the user experience was it was a lot faster because you would start to see stuff instantly, and as the images came, you would see them as soon as they were available. So that was a huge improvement. For Netscape 2, they wanted to take that same model except allow for programmability so that you could do the sorts of things that you could do in HyperCard on a web page. And so now you've got this basic flow. And this is now the inner loop of every web browser. So we start with an event. And the event could be the fetch box telling us something has loaded. We've got an onload event. Or it might be a timer event has just fired. Or it might be the user has typed something or clicked something or touched something. Or it might be that the operating system is giving some notice of something. Some event occurs, and that causes some script to run. Every event is associated with some script. And that script will run to completion. And in the process of running, it may mutate the page, may mutate the document tree, which will then cause reflowing and then cause repainting. And when it's done doing all of that, then we'll process the next event. So every script runs to completion, and we just keep going around and around like that. This is slightly oversimplified in that there are some events that a script can do which will cause reflow to happen immediately. So it won't necessarily wait for the end of the script's turn it'll happen right away. For example, if you put some text into a span, you can then ask the span, how many pixels wide are you? We can do that because it'll do the reflow immediately. But basically, that's how browsers work. Another of Netscape's innovations was the script tag. This was a way of getting the script into the page. Originally, they imagined that all of the scripts would be loaded inside the HTML. We now know that that's a bad practice, but they didn't know it at the time. And there's a problem from the very beginning, and that is, you remember the HTML rule that if you see a tag you don't recognize, you just ignore it and keep processing. So they had script tags that were recognized on Netscape 2, but they weren't recognized on Netscape 1 or on Mosaic or any of the other browsers. So if you were on one of those browsers and there was a script, the script wouldn't run, obviously, but you would see it. And so that looked stupid. So Netscape had to figure out a way to get around that. They couldn't fix Netscape 1 because it was already loose, and they couldn't fix Mosaic because that didn't belong to them. So they came up with a hack. They said, well, let's put a comment, an HTML comment, around the script. That way, if we display it on a browser that doesn't understand this, then at least you won't see it, which is technically in violation of the SGML rules, but HTML doesn't really follow the SGML rules very closely. I see a lot of people are still doing this, and they don't know why they're doing it. My advice to them now is, unless you expect your page to run on Netscape 1, you don't have to do this anymore. This has been unnecessary for at least 10 years. I recommend you don't have to do it anymore. Something that Microsoft added was the language attribute. And their motivation for doing that was they wanted to destroy JavaScript and replace it with a VB script. The reasoning was that JavaScript wasn't theirs and VB script was. It is rarely used for that purpose. Netscape actually embraced that. They thought they could use it to do versioning, which turned out to be a really bad idea, particularly when they got heated into the browser wars. I'll tell that story a little bit later. So recommend don't use the language attribute. It's been deprecated. The smartest thing that they added was the source attribute. That allowed you to load script as a separate file. And that has huge benefits in that you can minify the contents of that file and you can compress them. And you also have proper caching and more control, reuse. It's just a smarter way of doing it, division of concerns. So the recommendation now is, as much as you can, avoid putting code onto pages. Then something that was added later was a type attribute. And there's a problem with that the official MIME type for JavaScript is application/ECMAScript. But a lot of the older browsers don't recognize that. They only recognize text/JavaScript, which is not the approved MIME type. So you're faced with a choice of which standard do I want to be in violation of. But even worse than that, the server is authoritative as to what the type of the file is. The page is not. So it's actually ignored. And so my advice is don't put it in there. Just leave it out. Now the argument about that is that there are W3C rules that say it's required. And I say the W3C rules are in error. They did not understand how the web worked when they wrote that rule. Just not unusual. But I see people get really exercised about that. There's a devotion to web standards that is completely unjustified. And this is just one example, a trivial example. It's as if, and the gods gave us the web standards, and deviation from the web standards is the source of all evil. It turns out there's no truth in that statement at all. I know the guys who made the web standards. And there were some really bright guys in those numbers, and there were some other guys who were not nearly that bright. There was a lot of time pressure. There was a lot of mismanagement. A lot of mistakes were made. Given the process that put it all together, it's amazing that it's as good as it is, but it is way far from perfect, and it's way less than we deserve. So anyway, getting back to how browsers work. One of the worst things that they put in was document.write. They thought they were being clever in allowing insertion of text into the HTML document by a script that's in the HTML document as the HTML document is being parsed. That sounds like a crazily complicated kind of thing, and in fact it took a long time to get that to work right. And even then there are some problems. For example, there are the timing problems. If you do that while the page is still loading, you get some insertion, but if you do it after the page has loaded, then you destroy the page and replace it with the new text that you're writing. So you can't defer scripts that do document write to a later time. It's messy. It's not recommended. There are also big security problems with it and huge performance problems with it. It causes big performance problems in the browser even if you don't use it. So this is one of the features that we're trying to get rid of someday. Unfortunately, there's a lot of really nasty, terrible systems that are totally dependent on it, and I hope someday we can get them cleaned up. So because of document.write, where you put a script tag within a file can have a huge impact on page loading time. So the recommendation is place the script source tags as close to the bottom of the body as you can. The reason for that is that when a script tag is running or is loading, the browser has to be pessimistic about what damage that script might do to the document that it hasn't parsed yet. So it will stop downloading of assets. So it'll stop looking for images that it can load, not do anything. So basically everything gets frozen until the HTTP request to get the script tag completes and the script runs to completion. At that time, it can then resume HTML parsing. So if you have several script tags in a row, then you're going to go serial, stop, request, response, execute, stop, request, response. So it slows everything down. If you put it at the bottom, then there's a chance for all of the images that are in the document to be loading concurrently, and so you just get much faster performance. We also recommend that you minify and gzip the script files. That can also have a huge impact on startup time. And also to reduce the number of script files as much as possible, again, to reduce the number of round trips. I hope someday we can redesign HTML so that it's less sensitive to this stuff, so you can just do things where it's logical to put things and it'll do the right thing, but it's not that kind of system yet. So Microsoft and Netscape, through these years, were engaged in a crazy game of leapfrog, where each was trying to out-innovate the other. You know, we figured out how to do this. Can you figure out how to do that? Bet you can't do that. We did that. You know, we did it first. People are going to like us more than you, and so on. And they were kind of going off in different directions. And so for web developers, it was sort of like trying to stand in two boats at the same time that were drifting apart. Trying to make a program work under both of them became increasingly difficult. And through this process, a lot of mistakes were made. You know, blink tags and things like that are famous, but there are lots of other things that are more subtle that are still wrong. Late in the game, W3C attempted to moderate the truce between the two and get them to working together, and there was some limited success with that. So this is ultimately what they came up with. So what HTML is a language for describing trees. So here we've got a simple HTML document, and here we've got the tree structure that document represents. At the root of the tree is the document node, and in JavaScript in the browser there's a global variable called document, which is a variable containing that node. We've got the HTML node. There's no head node in my document here, but we've got one in the tree. There's some cases where the tree will fill in default nodes if we forget to specify something. Another example of that is in a table, you might not specify a t-body, but the browser will put a t-body into the tree for you, which can confuse you sometimes. If you're asking for a child of a table, expecting it a table row, and there's no table row there, you go, oh, where'd my table go? Another thing to notice is we've got the H1s and the Ps and so on. H1 suggests that it's a different level of structure, but in terms of HTML, they're exactly the same. They're all simple containers. So the H2s are not contained within the H1s, they're just separate. And then we've got nodes that represent the text in between. Now, this is the tree that's produced by IE. The tree that's produced by all of the other browsers and the later IEs under the compliance modes are much more complicated. They're much hairier. The reason they're much hairier is that they also contain text nodes for all of the useless white space that's between the tags. The Microsoft team early on thought, well, that's stupid. Nobody wants that text. It's insignificant. We're going to throw it out anyway. All it does is clutter up things and make them slower, so we won't put them in the tree, which makes a lot of sense. But the W3 rules say you can't do that, which doesn't make a lot of sense, but those are the rules, and that's what the other browser makers did. The difficulty for us is that you need to be prepared to deal with the tree in either form. It might have the silly white space in it, or it might not, depending on what browser you end up on. So your code needs to anticipate that and be resilient about it. We've got document.body, which gets us a shortcut to the body tag, so you don't have to traverse for that, so that's nice. And there's document.documentElement, which gets you to the HTML tag. You might wonder, why isn't it document.html? Why they come up with this goofy thing instead? It's because they were hoping to kill HTML, because W3C didn't believe in it. And so they wanted to give it a more vague name so they could change it to XML or XHTML or some other thing in the future. But that's not going to happen. So let's look at this in a little bit more detail. Same document now. Each of the nodes contains pointers to other nodes in the tree. Every node has 2 pointers, the first child and the last child. So the first child, at least in the IE case, points to H1. For the other browsers, it's going to point to some white space in a text node. And then the last one points to P. And then there are no direct pointers for the neglected middle children. So only the first and last get that kind of parental attention. But they're not completely left out because they're sibling pointers. And so each of the siblings has pointers to its previous and next sibling. The text nodes down at the bottom are not siblings, they're cousins. And you'll be glad to know you don't have to worry about cousin pointers. We don't have those here. Then each node has a parent node which points up to the node which is its parent. So there are a lot of pointers going on here. So you might think, okay, if I'm manipulating the structure, do I have to keep all of these things up to date? Unfortunately, the answer is no. The browser does that for you. So we'll see in a bit. There are some commands for manipulating these things, and they take care of all the pointer management for you. So that's good. But even so, there are a lot of pointers here, and you actually don't need all of these pointers. They're only, if you just want to do a regular recursive transversal of the structure, you only need 2. Because a binary tree will do that. So using just the first child and the next sibling is enough to get you to everything in the structure if you understand how to use recursion, which you should remember from last time. And if you don't remember from last time, this is how you can do it. So this is a recursive function which will visit every node in a tree or a subtree in the same order that they'll be displayed in HTML. So I call my function walk the DOM, and I pass in the node that I want to start with. You could pass in document or document.body. And then I'll also pass in a function, and that function will be called for each node that we visit. And first we'll go to the first child, and then we'll go through all of the siblings of that child. And for each node that we find as we go along, we'll then recursively call walk the DOM to get at its children and its siblings and so on going down. Right? Yeah. Okay, so why don't we take a break now? You can study this, and we'll come back in 10 minutes. All right, so let's resume. So, okay, so that's the walk the DOM function. So let's look at an example of using it. So the DOM does not provide a getElementsByClassName function. And that turns out to be a really useful thing to have. So I can do that by using walk the DOM. So I'll pass to walk the DOM a function. And that function will look at the class name property of the nodes that it is visiting and look to see if it contains the name that it's trying to match. And if it does, it will then add it to its set of results. And when it's all finished, it returns that set of results. Okay, so that's an example of using it. So just for completeness, there's one other set of pointers that are available. Every node has a list of all of its children, or all of its child nodes. So some nice redundancy there. There are methods available for retrieving nodes. The most efficient is getElementById. So if you happen to know the ID of a node, you can get at it very quickly. There's also getElementsByName and getElementsByTagName. These return not arrays of nodes, but node lists, which are freaky, weird things which are live queries on the DOM structure. And so they can have surprising inefficiencies, unfortunately. I think that was a terrible mistake. So once you get a hold of a node, then you can mess with it. Nodes have properties, and you can assign things to those properties, and by doing that, you can change the way it appears or change its behavior. For example, this is an image tag, and on an image tag, you can change its align, its alt, its border, its height. The most useful thing to change would be its source, so you can change what picture it points at. And the notation for doing that is extremely simple. It looks just like a JavaScript assignment. So you're on the node variable, whatever it's called, dot the property name, whatever that's called, and then an expression. In the W3C negotiations, they decided that was too nice, too elegant. So they came up with something that required a lot more typing. So you can say get attribute and pass in the name of the property, or you can say set attribute and pass in a property and a value. It's like they weren't comfortable with JavaScript. They really didn't understand how JavaScript worked, and so they came up with interfaces that looked much more like Java. And it works in JavaScript because JavaScript is a very capable language and is better than Java, but there are things that JavaScript can do that Java can't, and that was not included in the W3C design. Another thing you can do with a node once you get your hooks on it is style it. So you can set its class name. And the reason it's called class name and not class is because class is a reserved word in JavaScript, and there was a mistake in the design of the language which said you couldn't use reserved word in the dot position, which was just wrong. We fixed that in ES5, by the way. Thank you. Thank you. It's broken on everything before ES5, which is everything today. So the workaround was to call it class name, which is not a good name because a class can contain multiple names. So it's quite confusing. You can also get at the style object of a node and change any of its properties. Sometimes you want to look at a style property, perhaps before you change it, or perhaps because you want to know because, say, you're doing your own layout or something. So in IE, they provide a very nice way of doing that. There's a current style object on each node, which will get you the current value. The W3C model has something that looks much more Java-like. It's really awful. I'm not going to read it out loud. It's just too offensive. So the question to you is, which one do you use? And the answer is you have to use both all the time because one works in IE and the other doesn't. You have to do both. It's really awful. CSS and JavaScript were both designed about the same time, and both projects were aware of the other. But they could have made them work together well, and they intentionally chose not to. For example, when CSS was being designed, they knew it was going to be used with programming languages. It was a computer model, after all. But they chose to use hyphens with full awareness that most programming languages use hyphens to do negation or subtraction, and so that wasn't going to work. They didn't have to do it this way, but they did. At the same time, at Netscape, when they were working out the DOM model, they knew that the DOM or that CSS had come up with this hyphen thing. So they had a number of options. They could have said, okay, we'll just require these things be used as strings. So you put quotes around them and maybe put them in brackets, and that's just the way we'll do it. It's a little ugly, but the names are the same. Or they could have said, let's substitute underbars for the hyphens, so that way there's a simple transformation, so you can just do a quick search and replace and change it. No, they said, let's do camel case, the thing which is least compatible with the thing that CSS did. They had, both of these groups had an opportunity to make this like a system, and they both refused the opportunity. Damn them. It's not a big deal, but has anyone ever made a mistake using the wrong name in the wrong context? I mean, it's just, they could have made it easy, and they made it hard for no compensating benefit. That's a really bad trade-off. The last weird one is float gets changed to CSS float or style float on some systems, because float, again, is a reserved word in JavaScript, although it's not used in JavaScript. And again, we fixed that in ES5, thank you. But it's still wrong in the DOM. So even though it's right in the language, it'll always be wrong in the DOM. The DOM will always be wrong. So we talked about how you can find nodes. You can also make your own nodes. So you can call document.createElement or document.createTextNode and make nodes. Yay. And when you make a node, initially it doesn't do anything. It's not attached to the tree, so it can't be seen. It has no effect. But you can still manipulate it and do stuff with it, and eventually you might paste it into the tree and then it will appear. There's also a clone node, which will take an existing node and make another one that's pretty similar to it. And if you pass it true, and if the node has children, it'll also do clones of the children as well. So once you have nodes, you can then paste them into the document, and there's some methods for doing that. There's append child, which makes sense. It adds something to the end of the list of children for a node. There's another one, which is insert before, which looks a little strange, and replace child looks really weird to me. I would think that you would call that on the node that you want to replace, but instead you call it on the parent of the node that's the container of the child that you want to replace. So what you really have to write is old.parentNode.replace new old again. Again, this is Java thinking. You do stupid things in Java. You shouldn't have to do this in JavaScript, but that's the way they designed the DOM. Similar thing with remove child. You don't tell the child to be removed. You tell the child's parent to remove. That looks backwards to me. Also, because of a tragically terrible, stupid bug in IE6 and IE7, before you remove or replace a node, you have to be sure to remove any event handlers from it. Otherwise, you'll get memory leaks, and eventually your application will die. The W3C committee that was putting this all together, it never occurred to them that people would want to process their own HTML text within a script within a browser. So according to their plan, if you have some HTML, you have to parse it yourself. You have to write a JavaScript program which parses the HTML, builds a tree using all the primitives that we saw, and then put it all together, which is terrible. Microsoft recognized that that was terrible, so they came up with something called inner HTML, which is a bad name for what it does, and I think it's a bad API. It has so many side effects, I would rather it have been a method rather than a property, but still it works. And it turns out something that browsers are really good at is parsing HTML and building trees. So this can be a very effective way of doing things. Unfortunately, it's a security hazard. If you have any user-generated text that's getting put into the structure, particularly user-generated text coming from a user other than the principal user, which happens a lot in social applications, there's a very nasty mode in which a malicious user in a social context can put something in text which would ordinarily be benign, which will do things like close a string, close a tag, open up a new tag, which loads a new script or something like that, and then does that. So you need to be really careful in generating text to go to inner HTML. All of the other browser makers recognized that Microsoft was right in this and that the W3C model was deficient. So all the browsers implement inner HTML even though no standard requires it. So it raises a question for the developer, which one should you use? Should you, if you're making new content to put into a page, should you build each of the nodes individually and paste them all together and plug them in? Or should you build up a big text and use inner HTML to do that? And my advice is do the one that favors clean code and easy maintenance for your application. This is, in most cases, not something that should be decided in terms of performance. Performance should only influence you in extreme cases. In ordinary cases, if performance is not going to be undermining the user experience, choose the one that makes the most sense. If performance is an issue, then you want to use inner HTML, because browsers are really good at that. And even though it appears that the browser is doing a lot more work, it goes a lot faster. And I'll tell you why in a little bit. First, we're going to look at events. HyperCard was a system that was surprisingly easy for beginners to program, and it was completely event-driven. There are some people who think that event-driven systems are difficult. They prefer threaded systems or other things. But it turns out events are really simple. HyperCard did it really well. The browser, the DOM, does not do it as well as HyperCard did, but it still does it pretty well. So the browser has an event-driven, single-threaded, asynchronous programming model. Events are targeted at a particular node, and the events will cause invocation of an event handler function, and that function will then run until it completes, and then the next event will go. And there are lots of different events available. There are mouse events like clicks and things. There are input events like blurs and inputs and stuff. There are event handler APIs. There are 3 of them. There's the original Netscape one, which is supported in all browsers, which is you have a on-type property on an object like on click or on mouse over, and you just assign a function to it, boom, event handled, and it works really well, and it works everywhere. Microsoft came up with a variation of that in which they have a method called attach event, and then W3C decided there wasn't enough typing involved in that. So they came up with add event listener and added an extra parameter, which you usually want to set to false. And in a moment, I'll show you what that parameter is. A handler takes an optional event parameter, which describes what the event is and what it's all about. And generally, the program needs that information in order to know how to process the event. The reason it's optional is that Microsoft does not send an event parameter. Instead, you have to go out and find the global event object instead, which they now recognize was a mistake, but that's how they did. So when you write an event handler, you need to be prepared to do it both ways. So this template will work in all browsers. So we pass in E, which will be an event object in most browsers, but not on the lower IE series. And then we will replace E either with itself, if it's truthy, or with a global event variable if it's not. And that'll take care of the Microsoft case. And then we want to know what object are we talking about. And that's stored in the event, but it has a different name depending on what brand. And again, there's no excuse for that, but that's how it works. But you can get around that as well. It's either called target or source element. And then after that, you do whatever you have to do. There are 2 modes of how events get dispatched, the trickling mode and the bubbling mode. Trickling is an event capturing system that provides compatibility with Netscape 4. Netscape 4 did trickling. Netscape 4 was wrong. That's why there's no longer Netscape. Microsoft did it the other way. They did bubbling, which is the right way to do it. That's the way HyperCard did it. It's a bottom-up thing, where the event starts with the target node. If the target node doesn't handle the event, then it gets handed to its parent, and if it didn't do it, then to its parent, and so on until we get back up to the top. Much more rational way. When W3C sought to reconcile the Microsoft and Netscape modes, they couldn't agree on which way to do it, so they decided to do it both ways. Yeah, but you don't have to, so you should just do the bubbling. So why do you care about bubbling? Okay, suppose you've got a page in which you've got 100 draggable objects. One way you could do that is you could attach 100 sets of event handler functions to those 100 objects. And that's actually going to take some time. You can feel that time. Your users can feel that time. So generally you don't want to do that if you can avoid it. The other option is you can add just one set of event handlers to the common parent object of all of those nodes. And then that parent, when it gets the event, can then ask, okay, which of my many children does this concern? And then dispatch it itself. And in doing that, we can significantly cut the overhead in managing that page, and that can have huge benefits. So once an event handler has decided, okay, I've taken care of it, don't tell my parents, we're all done here. The way you do that is to cancel the bubbling. And there are two ways to do that depending on what model of browser you're on. And so you have to do it both ways, because either could happen. The other thing that could happen is a default action. There are some things in the browser which will do something if an event occurs on them. For example, if you click on a submit button, a form submit will take place. It might be you don't want that to happen, that you want to intercept that and cause something else to happen instead. So to prevent the browser from taking off on that, you call prevent default on the event object, and that causes the browser to let it go. So dealing with the browser has terrible performance problems. Every time you touch a node, there is a cost, especially on IE, because in IE, nodes live on the other side of an ActiveX boundary. So there's a marshalling expense paid every time you touch a node, look at it, going and read it or touch it. So it's something you need to be aware of. So for example, the recursive function that I showed you earlier, it's actually really slow because it has to go and visit every node and touch every node, and touching all those nodes is expensive. Styling can have an even bigger cost because when you style something, it has to search through the cascade and determine what the consequences of the change are. And sometimes those can be very costly. Sometimes when you change the style, that's going to cause a reflow. Reflow can be really expensive. Sometimes just asking the browser for something like a margin, there are 4 margins, you ask for them, you end up doing 4 reflows, and you didn't even change anything. There are those sorts of unexpected awfulnesses that can occur. Repainting can have a big cost. And there are random things like node lists that can have unexpectedly huge costs. So in most web applications, JavaScript is a very small cost. Most of the cost of the application in terms of time is being spent in the DOM where you can't see what's going on. You're doing these nice little things in JavaScript, manipulating these nodes, and unexpectedly, things go really slow. And there are things that you cannot see that if you did them differently, you might see completely different performance. For example, if you're building a structure, if you say, I'll put a node into the tree and then put its child on the tree and so on and build it from the top down, that's really slow because each time you add one of those nodes, you may pay for another reflow. Whereas if instead you build the thing independently from the bottom up and then plug the whole thing in when you're finished, one reflow. And so that'll go a lot faster. There are things like that that you wouldn't expect that are in this model. And I see people trying to optimize their code without understanding how this model works and without any visibility as to where the time is going. And they'll do things like fiddle with their code and go, well, maybe if I change that multiply to an add, it'll go faster. And that stuff is completely in the noise. It has no effect on what's going on. So in order to optimize, you have to have good numbers in order to understand what you're doing. And fortunately now, recently, we finally have some tools that allow us to do that. Because up until now, the browser's been a black box. We had no information as to where the time was going. But we do now. There's a wonderful tool on Chrome called Speed Tracer, which will analyze your program and show you how much of your time is being spent in doing reflows, how much time is being spent painting, how much is being done in styling, how much is in JavaScript. There's also a program for IE called Dynatrace, does similar stuff, great stuff. Don't optimize without good tools like this. We're still completely in the dark on Safari and Firefox and Opera. Hopefully they're listening and they're going to follow through and give us good tools there as well. So all of these standards were being developed in the context of intense competition. Again, not a good, thoughtful process for creating standards. And then suddenly, Netscape self-destructed, and the browser war was over. Now, there's some people who are angry at Microsoft for having destroyed Netscape. Microsoft, in fact, did terrible things during the browser wars, but I believe that Netscape's destruction was caused by Netscape. Netscape was a horribly mismanaged company. They're also a company without a business plan. Their original model was that they would make web browsers, give them away to everybody, and then once it got everybody hooked, charge everybody $30. And that didn't work. And the reason it didn't work was because they went around saying, yes, and with the browser, we're going to destroy Microsoft. And Microsoft said, what? Because Microsoft had paid, up until that point, no attention to the web. Microsoft thought that the future was going to be in things like CD-ROM, fax machines, and Windows-based cable set-top boxes. They really didn't see the internet thing. So they were paying no attention to it. And then suddenly, this little company, Netscape, was going to destroy them. And so what? You know, they were blindsided by that. So it's, okay, we need to get in there. And they saw that Netscape was giving away browsers. So they decided to do the same thing. Now, if you know Microsoft, you know that is not a company that likes to give things away. So they didn't get into this lightly. But because they did that, they made it impossible for Netscape to charge, and so they were now without a business model. And they had raised a huge amount of money in their IPO, and eventually they spent it all and never came up with a model, and they went down. And in the meantime, they shipped a lot of crap, and so they kind of destroyed any other opportunities that might have come to them. So at that point, Microsoft went, whew, okay, we dodged that bullet. You know, the web is done, so enough of that. Forrester said it's not going to happen anyway, so X-Internet, yeah, we should get on that. So they pulled everybody off the Internet Explorer team. Said, good work, guys. We're done with the web. We're going to go off to the next thing. We're going to do the X-Internet. And they developed a whole new application framework that they called .NET, which was going to be their X-Internet platform. And they were going to go off into the future that way. Then suddenly, Ajax happened, and the web blindsides Microsoft a second time. And this must have been really ironic to Microsoft when they consider their history in this game, because look at what they did. They developed JavaScript, which was a high-fidelity clone of JavaScript. If they hadn't made it so good, we wouldn't be talking about JavaScript tonight. They generalized the document model. They made the DOM good enough that we could write applications in it. It's not good enough to be pleasant, but it's good enough to work. And they came up with the XML HTTP request, which is, you know, the primitive thing that you need in order to do the data. They declared victory and left the field, said the browser war is over, but left behind the potential seeds for their next destruction. Because 5 years later, Jesse James Garrett discovers Ajax. So had they not done all of those things, Microsoft or JavaScript would have died with Netscape. There are lots of companies that developed proprietary programming languages, and when the company goes away, the language goes away, and that's it. And that should have happened to this one. But it didn't, because the Ajax revolution gave JavaScript a second chance. And the Ajax revolution succeeded because of the goodness that was in JavaScript. So again, 2000, all of the features needed to do Ajax applications were in the field. And then 2005, Jesse James Garrett discovers Ajax. So 5 years. What was happening in those 5 years? Why wasn't Ajax discovered in 2000? Why did it take 5 years to happen? It's because the web was full of bugs. During the browser wars, both sides were pumping bugs into the web at a furious pace. And in the web, as you know, bugs don't go away. Once you ship a buggy browser, you can't depend on all the people who receive that browser upgrading. So when they shipped a bug fix, some of the users would get it and some of them wouldn't. So from the developer's point of view, it's still broken. And in fact, the bug fix might have contained new bugs. And so that comes with another bug fix. And the bug list keeps getting bigger and bigger and bigger and never gets smaller. Well, eventually it does get smaller, but it takes 5 years, at least in this case. It's because most people don't install new browsers. They replace their software when they replace their hardware. They don't want to think about maintaining software. They just want to click on the E and get to the internets. And that's all. They don't want to think any deeper than that, and they shouldn't have to. There are also technologically backward companies who will lock their machines down. So their users, even if they understand the reasons for why they need to upgrade, can't. Back in 2002, I was working with a couple of companies who refused to allow their users to use IE, that they had to use Netscape 4, even though Netscape had already lost. And those companies were Sun Microsystems and IBM. In fact, Sun continued to maintain Netscape Navigator even after Netscape had given up. And in the process, they were creating more and more bugs in the Netscape 4 area. So it took years to flush Netscape 4 and IE4 out of the market. There weren't enough users on good computers, on good browsers, to make it a viable platform for application development. It took years to restabilize the web after the disruption of the browser wars. So in the browser wars, the browser was a great driver of innovation. We saw all kinds of new stuff happening. The browsers were doing new things. We were developing new models. We developed Ajax and all that stuff. The browser has become an obstacle to innovation. That's not where we can innovate anymore, and it's actually frustrating our attempts to innovate. Web time used to mean that things moved really fast. Netscape used to brag about, we're in web time. And every couple of weeks, they'd ship another version of their browser, and the early adopters would pick it up, and they'd all move forward together. But as we go mainstream, as we get more and more people on, the early adopters become insignificant. And you've got 1 billion people on the net who are not interested in upgrading. And at that point, the browser turns into a barrier. The browser makers can try to put new features in, but they cannot force users of old software to come up to speed. And so from the perspective of developers like us, we just can't use the new features. So we cannot innovate there. And also, every mistake they ever made is out there, and we pay the price for those mistakes. So with Ajax, the source of innovation shifted from the browser makers to the web developers in the form of Ajax libraries. Ajax libraries are these wonderful things in which we're exploring powerful new ways of building applications and doing it really well on a very broad front. It turns out, because JavaScript is such a powerfully expressive language, a surprisingly small amount of JavaScript can transform the DOM, which is one of the world's awfulest APIs, into something that is pleasant and productive. It's an amazing thing. Also, Ajax libraries are fun and easy to make. I know because I've made 6 of them over my career. They really are fun and easy to make, and there are a lot of other guys out there making them too. Some very bright guys over here doing some good stuff. And so there are a lot of them. We've got a lot of Ajax libraries that are all over the map in terms of functionality and features and stuff. And they all work very differently, and the main thing they all have in common is they're all really good. So what does an Ajax library do? These are the major benefits you get from an Ajax library. The first one is portability. Because of the crappiness of web standards and because of the crappiness of the implementation of browsers in general, it's very difficult to write a program that runs consistently on every browser, but we're required to do that. So one of the services that an Ajax library provides is correction of that, of improving the portability so that you've got an API which will work consistently on all of the current browsers. It will also correct some of the deep defects that are in the DOM model and raise the level of abstraction up to a place where we can be much more productive. The place where they tend to differ the most is in the model. They'll provide some new kind of programming model or object model or inheritance model or processing model, which may be inspired by some other programming language or some existing system, or might be wholly new. And so we're seeing an amazing amount of diversity at that level in all the libraries. And then they'll also come with widgets, ready-made bundles of functionality and appearance that you can just plug onto a page and will instantly do useful things for you. Wonderful stuff that we get from the Ajax libraries, and more new wonderful stuff being developed all the time. So having a lot of Ajax libraries, I thought was going to be a problem, because generally development markets don't like having that much choice. So a few years ago, I predicted that there would be a shakeout, and I thought that the market would reduce the number of viable libraries down to one or two. I thought one of the winners would probably be Microsoft, because they're always one of the winners. And then maybe YUI or Dojo or one of the others would be the number two. Turned out it didn't work that way. Pretty much all of the libraries are still thriving. The only one that failed that I can think of was the IE library, or the Microsoft library. Their Atlas thing didn't get much pickup. And the reason for that was that the Ajax application market is just so big. It is now the world's biggest development market, that there is room for all of this diversity, that every one of these libraries has its own community of users. They're all very dedicated, and each is big enough to support and sustain its own library. I expect there will be a shakeout eventually, but it will not come until mashups become viable. We're just on the cusp of that. When mashups become viable, then all of the components on the page, in order to interoperate, are going to then want to have a common Ajax library. And when we get to that point, then I think we will see the shakeout, but we're not there yet. So in the meantime, you've got this embarrassment of riches. There are a lot of Ajax libraries. In fact, instead of shaking out, the number has actually grown since I made my shakeout prediction. How do you choose? That if you want to take a careful examination of all the libraries available to you, it would take longer to complete that evaluation than to build a new one from scratch. In fact, I think a lot of people are doing that. They're just, okay, I'll build another one. Then it's too hard to figure out, should I use YUI or Dojo or jQuery? It's too hard. The Ajaxians recommended that you take all of the libraries that you're considering, put them on a board, and throw a dart and see which one you hit. I think you can do a little better than that. So let me offer this suggestion. Run them through JSLint. See what you get. JSLint is the only objective standard we have for JavaScript code quality. So try it out, see how they're doing. I have not tried this on any of the other libraries, so I don't know how they're going to do. I'm hoping that they all pass, but I'll bet you some of them won't. So through all of this, Ajax is no longer new or special. It's just the way we make web applications now. So Ajax has mainstreamed. It's just the way it is. So we're probably going to stop saying Ajax. It's just web development. And it has become the world's dominant application platform. And there's a lot of competition for that position, but right now the browser's got it. Even though the web is deeply deficient in a lot of ways, and some of the new contenders, such as Silverlight and Air, are vastly superior in a number of ways. There's still something about the browser which they cannot match and may not match. So the difficulty we have now is that the Ajax community has mined all of the latent potential of the 20th century browser platform. There's been a lot of really clever work in figuring out new models and new ways of using the browser in modes that it did not anticipate. And we've found a lot of latent capability there, stuff that the browser makers did not put in intentionally, but we found ways to exploit. We have used it all up. And so we're at the limit of how we can innovate, so we're stuck. Which brings us to the Internet Explorer problem. We would like to be able to bring all the browsers up to a new level, but that's just a waste of time until we get rid of Internet Explorer 6. Now, to give you a little background on this, for many years, Internet Explorer 6 was the very best web browser on the planet and continued to be the best web browser the world had ever seen for many years. Who's surprised at this statement? Yeah, everybody thinks, oh, IE6 is the worst thing anybody's ever seen. It was the best. It was absolutely the best. You should have seen Netscape 4. Man, that was a piece of work. So IE survived, Netscape 4 didn't, for good reasons. Microsoft deserved to have won that battle. But now we're stuck with it. Now, 5 years ago, I predicted that based on the amount of time that it took Netscape 4 to get flushed out, we'd see a similar problem or a similar period of time with IE6. So it took about 5 years to get rid of Netscape 4. I thought it would take about 5 years to get rid of IE6. That was 5 years ago. It's still here. We've seen some erosion of its market share, but it's still very, very strong, which is a problem because we need the new browsers. We need support for new features because we're at the limit of what Ajax can do now. But we can't and also support IE6, so one of them's got to go. And so we'd like to see IE6 go. And here, I can't give you the real numbers, but I can tell you the truth. There are more obsolete copies of IE6 in use than Opera, Safari, and Chrome combined. Okay? It's big. So, you may in your team be thinking, well, we think Safari is big enough, we should be supporting that, and Opera is big enough, we should be supporting that. You can't do that analysis and then say, but we're not going to support IE6 because it's huger than all of them. So it might be years before IE6 goes away, and it may never go away. It's fading very slowly. It's hanging on, and I think the reason it's hanging on is because we did such a good job in allowing it to. Because we've been really good at allowing our programs to work on IE6, even though that's painful to us, and even though that's destroying our future potential in the platform, IE6 is holding on. So, IE6 must die. A couple of weeks ago, I think, YouTube, anyone heard of YouTube? They announced that they weren't going to support IE6 anymore. It was great. But if you look at what they actually said, they said, well, we'll continue to let them see movies, but they won't get the new special features. It's like, who goes to YouTube for the new special features? And that's just stupid. So we need to have a statement, yeah, we're not going to support IE6 anymore, but we've got to have better teeth in it than that. And nobody wants to be the first website that has the teeth. I know that my company doesn't. We don't want to be the ones to say, IE6, scram, go off to AOL or Bing or some other place. We don't want you. Nobody's going to do that. So somehow we have to figure out a way to get everybody in agreement to pick a time and date and say, on that date, anybody who comes to us in IE6, they go to a referral page saying, you have to install one of these good browsers. I'm sorry, you're just not welcome anywhere in the world anymore. And unless we can accomplish that, we will have IE6 forever. And the stuff we're doing with HTML5 and everything else will not count, which would be sad. So speaking of HTML5, a big step in the wrong direction. In my view, it's way too complicated, way too much crap in it. There's some good stuff in it, and there's some very good stuff in it, very good, very bad stuff in it. The HTML5 committee cannot tell the difference. So I would like it to go away. I'd like to start over. I think there are definitely things that we could do better in the browser platform based on what we've learned in Ajax. That stuff's not being factored into HTML5, and that's unfortunate. Because it turns out Ajax developers are much better at this stuff than browser makers. You look at the quality of design in any Ajax library, and it's infinitely better than what we've got coming out of the browsers, and it's infinitely better than what we've got coming out of HTML5. So I think this community should be the community for deciding what the next version of the platform should be. Ajax is great, and the DOM is not. And HTML5 just gives us a lot more DOM. So ultimately, I think we should seek to replace the DOM with an Ajax-influenced API, because Ajax gets it right. What the particulars of that are, I don't know. It's really complicated, partly complicated because there are so many ideas about how Ajax should work. But we're starting to see some convergence on some things. For example, everybody is doing CSS queries now. That was a really good idea. Everybody's up on that. That should be standard equipment. But there's other stuff in Ajax which is similar to that that's not in HTML5. One last bit before we say goodnight. Division of labor. Ajax introduces some new complexities into application development, and I've noticed that even though we've been at this for a few years now, some people are still struggling with it. So let me give you a little bit of advice on this. It comes down to how is the application divided between the browser and the server. Historically, if you go back to Web 1.0, everything happened in the server. So that the only opportunity for interactivity you had was page replacement, which was very slow and very inefficient and very disrespectful of the users, but that's how it worked. And so we wanted to get off of that. So Ajax allowed us to go to the other extreme, and that other extreme turns out to be just as bad, where we treat the browser or treat the server as a file system. I've seen people complaining about the time it took to parse a gigabyte of data that they got from the server and saying, can we make that faster? I go, whoa, 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 whoa. Let's look at your fundamental assumptions here. Say you go to Yahoo Search or Bing or Ask or anywhere else and you Google for something. And the server will come up with, say, 10,000 matches for you. But it doesn't send all 10,000 of them. It sends you 10 or 20 of them because you don't want to wait for 10,000 things to get loaded before you get to make a decision. And chances are, if they sequence them right, you'll find the solution in the first couple of them anyway. So just sending all of them would be a huge waste. Turns out the same is true in Ajax applications as well. So you don't want to send everything that you had on the server over to the browser and do the whole application in the browser. You need a dialogue happening between the browser and the server. So seek the middle way. In my view, an Ajax application is right if it's structured as a pleasant dialogue between specialized peers. The browser has its role, the server has its role, and they're in a conversation with lots of short messages going back and forth, each maybe trying to anticipate what the next is going to do, but not trying to look more than one or two moves ahead. That turns out to be highly responsive, and once you get used to it, it's a very pleasant way to create programs. So that's all I've got for you tonight. I hope you'll join me last time for the final installment, Part 5, The End of All Things. Thank you and good night.